about it. This is going to help y'all a lot. So I want all eyes up here in the video. Okay, so we know what a rectangular prism is, right?
Yes, ma'am.
So we're going to talk about faces, edges, and vertices a little bit more. Go ahead and dim the lights a little bit, Zachary.
How can you describe parts of solid figures? Think about this question during the lesson. What solid figures did we study in the last
so we kind
lesson?
of talked about these a little bit, right? So this is a cube. What's this one? Cone. Sphere. Okay, yep, so pyramids, cylinders, cones, and spheres.
Some solid figures have faces, vertices, and edges. Each flat surface of a solid figure is a face.
So a face. So on a cube, what would all this be? Face. Yep. Same part of the rectangular prism. What would this be called right here? Face. Good.
How many flat surfaces does a rectangular prism have?
Okay, so how many faces? Let's count. 1, 2, 3, 4, 5, 6. Good.
A rectangular prism has 6 faces. A rectangular prism has 6 flat surfaces or 6 faces.
So it's always a flat surface.
Will a rectangular prism roll?
So could this roll? No, why not? It could, but not as easily as a sphere, right? No. Why? Devontae. Yeah, corners and edges, right? So it's not really like very easy to roll. William, eyes up here. Haley, eyes up here.
No, a rectangular prism will not roll. It does not have a curved surface.
Right, so no curved surfaces. What's another solid figure that may have a little bit of a curved surface that we talked about yesterday? We already talked about the sphere. Cone. Does this have any faces? It has base, but nothing compared to the rectangular prism, right?
Miss Brown.
Yes.
Hey, when is your homework packet due that was sent home yesterday?
I'm going to extend it through next week since they didn't get it until yesterday.
Okay, there was just a mom on the phone.
Is that Abby Black's mother?
No, Jerry.
Oh, okay. Yeah, it'll be due next week.
All right, I'll let her know. Thank you.
Thank you.
A rectangular prism has 12 edges.
So just count them. Just find them together. Okay, let's look up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. It's a little hard to keep track of, but we have 12 there.
How can you describe an edge of a solid
So
figure?
how can you describe an edge? William, how can you describe an edge? Yes. Bethany, what did he just say? Can you hear him? Can anyone else hear what William just said?
Yes.
Alyssa. When two faces meet. So let's look at that. Here's a face, right? Friends, yes, we see a face. Haley? Is there a face right here? So what does that create? The edge, right?
An edge is where 2 faces meet.
Because they pockets, friend.
A rectangular prism has 8 vertices.
Little green light hands on, friends. I got it. Okay. Okay, so rectangular prism has 8 vertices. Let's try and see them on here. It's a little bit bigger. So 1, 2, then there's one over here, right? 3, 4, 5, 6, 7, 8. So how can you describe a vertice, friends? Ethan, how can you describe a vertice? The sharp edges. That's a good way to meet, yeah. 3 edges meet. So let's look at that, Halima. When 3 edges meet. Right. So okay, let's look at this. 1, here's 1, 2, 3. Yep, here's an edge and there's vertices.
How can you describe a corner or vertex of a solid figure is where 3 or more edges meet?
So let's look. Here is an edge, here's an edge, and here's an edge. What does that create?
What's the vertex again?
Vertice. We just talked about William.
You might confuse the terms face, edge, and vertex. To help you remember, visualize the terms in relation to a room. A face is like a wall. An edge is like the place where 2 walls meet. And a vertex is like a corner, or the point where 2 walls and the ceiling meet.
So do we have edges, faces, and vertices in this room?
Yes, yes.
So what would this be? This long wall would be what? A face. How about up there in that corner? What would that be? Vertex. How about the wall that goes down? The edge. Very good. So they're everywhere. Okay. So I'm gonna give. Oh, I'll wait. I'm gonna give each table group a solid figure, and you're gonna become the experts on your solid figure. So I want to know how solid figure. What's a solid figure, Haley? The shape. What kind of things have you been looking at with shapes? Raise your hand. Ethan. Yes. What kind of things do we look at with rectangular prisms? Okay. What kind of other things? Emma. Faces, edges, and vertices. What's a face? Don't flirt, friends. Jose.
Like a flat wall on it.
Okay. Yeah, good. How about edge? Halima. Right. How about vertice? Last thing. Yeah. The point. So what are shapes made of? If you were to draw a shape, how would you draw it? What would you need? Mason. If you were to draw a rectangle, how would you draw it? You'd have to draw what first? Okay, let's go even more detailed. Emma. A square. How would you draw a square though? If I had no idea how to draw a square, how would I draw a square? Tell me, William.
4 even sides.
4 even sides. Okay, even more detail than that. What would I have to do? Give me more detail.
4 even sides shaped like this.
Okay, but what is it made out of?
Pencil.
Wood. Okay.
Well,
If I had a pencil, this is my pencil. How would I get started?
by making
Draw a line. Thank you. I would draw a line. So if I was to draw a line, and we weren't drawing a shape, this would be a line, right? It has arrows at the ends. Right. If I didn't have lines at the ends, I would have points. And my line would stop. So that's what we're going to start with today. We're going to talk about lines and details about lines. So I'm going to give you all a piece of paper. We're going to get started in just a second. Don't draw anything on your paper. Don't do anything with your paper yet. Devontae, you put your book up, please. You can look at it later, I promise. Devontae, put your book up. Okay, you can look at it later. We need math right now.
I'll look at it.
But I think you can shut the door. Here, Jose. Keep it this on back. 1, 2, 3, eyes and ears on me. So I want you to do what I do. Everyone's eyes need to be up here. You can just use a crayon or a pencil. It's gonna be okay. Or a marker. So you are going to start off by drawing a line segment. Watch me. It's off the point. You're going to end with a point.
Okay.
So this is called a what? Line segment. Does it have arrows at the end? It has arrows at the end, Ethan? No. This means this line starts right here and ends right here. If I was to draw arrows at the end like I did earlier, that means it goes on forever and ever. There's no endpoint. Huh? Yes, like a period. I like that.
Yeah.
Okay, now I want you to draw a line that's kind of like below it.
Oh, I know.
Doesn't really have to be exactly the length of it. It could be longer, shorter. But it does not cross it.
Right
It
here.
does not touch it, does it?
Right here.
No. Thank you, Bonnie. I see. I'm proud of you. Okay, so those are called parallel lines. Do they touch?
No.
No. But is it the same direction?
Yes.
Yes, it's going horizontally. They never touch, but they're going the same way. Okay?
Wait, let's make a V again.
Good. Okay, now we're going to make a line that crosses it. It crosses it. This is called an intersecting line. Why is it intersecting? What does the word intersect mean, William?
Go across or
Yeah, so it touches it, right? Yeah, so it can cross it. Okay, so that is an intersecting line. So we're going to go to these terms one more time. Okay, what's this one called? This is a line what? Line segment. Why is that a line segment, Jose? They go straight. But what makes it special? What makes it different from a line? It doesn't go on forever. Now, look at this line that I draw. If this was to intersect, what makes this different, Emma? It has arrows at the end. What do the arrows mean, Abby? What do the arrows mean, Halima?
That means that they go forever.
Ever and ever. Okay, so what is this line right here? This one I'm outlining in blue. What is this line called? It starts with an I.
Intersecting line.
Intersecting line. What makes it intersecting?
We have to do it with because it crosses or touches it.
Crosses and touches. And our last friend of a line is right down here. I'm outlining it in green.
Ooh, that is neat.
So what is this line?
Line segment.
This is a line segment, but what's its relationship to this top line? Starts with a P. It's the same. What makes it the same?
Because it like has the same. No.
Yeah, it goes the same direction.
It goes the same
So it's-
direction. It goes up and down.
She's thinking about it. Parallel. Parallel. So we're going to go to these terms again in the video. But I wanted y'all to make sure you did it yourselves. So we have parallel line, line segment, and our one in blue is an intersecting line.
What is second?
Intersecting. So, I'll wait.
What in the world?
Where can you see these lines in real life? What's a good example?
Railroad.
Roads.
Railroad.
How? Railroads. How are railroads an example, William?
Sometimes there'll be one line that turns into two, and basically one line intersects.
Do some roads intersect?
Yeah.
Where do they intersect at?
At crossing points.
Crossing points. What are those called? It could be stoplights, right? Or stop signs. Right. So you have two roads intersecting. Do some roads never touch though?
Yeah.
But what's special about them? They're going the same direction, right? Yeah, so those are parallel roads. So if I'm sitting at a stoplight, there's roads around me, right? So we're intersecting. But railroads don't always intersect, right? No, and some roads